system design, and basically I'm just like repeating lecture number 1. Okay, we have two sides. From the memory, we have the microprocessor side, which is shown in the red color. Now we have the memory side, which is shown in the black color. Okay, so please, I need your attention. If you look at here, so now you have something M. What is M? What is M? Width of the address bus. This is the width. This M is the width of the address bus. So this is my address bus. So this is my width of the address bus. W, what is W? Data bus. Okay, CS stand for chip select, OE stand for output enable, W stand for write enable. So these are the signals we studied in our first lecture. And if remember, if CS is 0, chip is disabled, is 1. So OE is 0, W is 0, no read write. W is 1, write operation. OE is 1, read operation. And this is an invalid combination. Remember, this is your memory side or microprocessor side? Memory side. It's your memory size. Okay. What will be the memory size? Can you tell me? We did in our first lecture.
2 to the power of m times by 2.
So basically, if you look at here, the memory requirement. So basically, please remember, in general case. Now I'm not using the black color. So memory available. Let's assume we have a memory available. Which is the total memory will be 2 to the power m cross what?
W.
Now look at the microprocessor side. A stands for address lines. Address lines. D stands for what?
Data lines.
Data lines. So okay, the memory requirement from the microprocessor is now memory requirement. What is the memory requirement? Anyone? We have the address line A. Address line, if it's M, so 2 to the power M cross W. What is A? Address line D? Data line. So the memory requirement will be what? 2 to the power A
by D.
cross what? D. So now we will study 4 different cases. Scenario 1, scenario 2, scenario 3 and scenario 4. We will study all of these cases. So this is my first lecture, so I am now repeating my first lecture. Can you see here? Remember, this is my memory. What is now M here? M is now 3. How many? So what is my memory in this example? So what is the memory available? So the memory available, please remember, the memory available will be what? 2 to the power 3 cross what? W. So 2 to the power M cross W. What is M? M is 3. 2 to the power 3 cross W, which is 4. Okay, 2 to the power 3, how many locations do we have? We have 8 locations. So we have 8 locations. So we have how many locations? We have 8 locations. Each of how many bits? So we have 8, which is actually 2 to the power M. We have 2 to the power M, which have 8 locations. Each of how many bits? W is equal to 4 bits. Clear or not clear? What is the address of the first location? 0, 0, 0. What is the address of the second location? 0, 0, 1 and so forth, so on. What is the address of last location? 1, 1, 1. Remember my first lecture? Okay. If we want to access the first location. Okay, now can you see here? What is M? We want to address this location. But chip select is what? 0. If chip select is 0, the memory is enabled or disabled? Disabled. No read or no write operation. Remember my first lecture? So I am now going to repeat. I want to now access, can you see here? What is now my address here in this case? 101. 101, we want to access this location. Chip select is enabled. Read operation or write operation?
Read operation.
Read operation. Okay, which location we want to read? 101. What will be the new value? 00?
1.
Clear? Then we have read operation or write operation? Write operation. Because W is 1. Chip select is enabled. Okay, so now microprocessor has to provide the data. Microprocessor has to provide the data through what? Through MBR. Remember? So this is how I'm now going to. This was a small example. So now this is the microprocessor side. Okay, microprocessor have one signal address trope. If address trope is 1, what does it implies? Microprocessor has generated a valid address. If address trope is 0, the address is invalid. Okay, now we will study 4 different cases. And remember the instruction fetch stage. Remember, we have the fetch stage, then we have the decode stage. So now we have an address. When we are fetching the instruction, we are in the instruction fetch stage. Okay, it's a read operation. Instruction fetch is a read operation or write operation? Read operation. Okay. What will be value of address trope? 1. What will be the value of read write bar? 1. Got? Address lines. So the address lines A will go where? MAR. Clear? The address which is loaded into the PC address, remember? And then what will be the data lines? The content of the MBR. And it will go where? To IR. Remember? Then we have decode stage. But because, do we need to access the memory in decode stage? No. What will be the value of address store? Clear? Operand store. Do we need operand store? If you are writing RD, write backstage. No. Okay, the operand store. Operand store means STR instruction. When we are having the STR instruction. So please remember. So now in this case, please remember. Now we are storing this data into disk memory location. This is now the effective address. Okay, what will be the data lines? 98. Address store will be 1. And which data we are writing? 98. So 98 will go to MBR. Please remember, this is another assembly. Move. This is not LC3 assembly. This is another example. So it means that we are writing a value of 98 to this memory location. Clear? So this value will go to MAR and this value will go where? MBR. Okay, now we have case number 1. Please remember. Can you see here? There are 4 different cases. So case number 1. So we will study case number 1. So please remember, case number 1 is here. Case number 1. When A is equal to M, A is equal to M and D is equal to what? It means that the address line from the microprocessor side is equal to the address lines on the memory side. Clear? And then D is equal to W. The data lines from the microprocessor side is equal to the data lines from microprocessor. We will do it with one example. What is that example? Let's see. Okay. What is now the, okay, now can you see here? So, please, question. What is the memory requirement of microprocessor? 4 kilobyte. So the memory requirement of microprocessor is, so memory on the microprocessor side is what? How many? Memory on the microprocessor side is equal to 4 kilobyte. Am I right or not? If the memory on the microprocessor is 4 kilobyte, so we are on the microprocessor side or the memory side? Microprocessor side, memory requirement. Which formula should we use? 2A cross D or 2M plus W? 2A cross D. So the memory on the microprocessor side is 4 kilobyte, which is given, and it will be equal to 2A cross D. Okay. And the width of the data bus, please remember, the width of the data bus on the microprocessor side is 8 bits. What is D now here? So the memory of the microprocessor is 4 kilobytes. Okay, now I'm going to, so the memory on the microprocessor side is 4 kilobyte. The data bus on the microprocessor side, okay, what is the data bus on the microprocessor side? How many bits? 8 bits. So if we are considering the data bus on the microprocessor side, we call this as D. So D is given 8 bits. What is missing? A is missing. So it means the address bus on the microprocessor side, A, we need to find A. So we plug this into formula. So we have 4 kilobyte. So 4 kilobyte is equal to 2 to the power A cross what? D. What is 4 kilobyte? 2 to the power 2, 2 to the power 10, 2 to the power 3 is equal to 2 to the power A cross D. What is D? 8. Clear? Okay, if you compute it, so this is actually 2 to the power 2, 2 to the power 10, this is actually 2 to the power 12, dot 8 is equal to 2 to the power A cross 8. 8 will cancel out. What is A now? Help me. Now look, what is now the memory available? Memory available. What is memory available now? 2 to the power 12 plus 8. Okay, now using the another thing, memory available. So now this is my memory available. So the memory available is equal to what? 2 to the power M cross what?
W.
W. So the memory available is given. It is actually 2 to the power 12 cross 8. It is equal to 2 to the power M cross W. What is M here now? What is M in this example? 12. So M is 12. And what is W here now?
8.
W is 8. So this is case number 1 or case number 2? Case number 1. So this is now case number 1. Please remember, this is now case number 1. A is equal to, in this example, what is A? A is equal to M is equal to 12, and then D is equal to what?
W.
W is equal to. Okay, now we want to connect this microprocessor with the main memory. So now we have microprocessor with the main memory. Please remember, I'm telling you this is now 33% or 1/3 of your midterm 2. Okay, so I'll not repeat it. So if you look at here, now we have the microprocessor side. So now this is my case number 1. So this is now my microprocessor side. How many address lines are there on microprocessor side? How many address lines? 12 bits. So if you look at here on the and please remember, this is very important. So that's basically what I'm going to do here. Okay, so please remember, this will look like this. So it will be what? Help me. This will be A11 because the address line is 12. Then what? A10, A09, blah 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 blah. Okay, I'm not putting dot because I cannot do all these things. What will this? The last line. Help me. A00. So what can you see here? Now what is my A here now? A is what? 12. Then what do we have another thing? D. Okay, so data lines. So now I'm now doing it with the black color data lines. So my data lines, so D is now 8. So what is now my data lines? Help me. D07. So because this is D, so I will use the index D. Then D what? D06 and then what? D00. So now these are my data lines. Clear or not clear? Okay, now please remember, now we have the address lines, which is 8. Now we have the data lines, which is 8 bits, and then we have two control signals. The first control signal, now I'm using it, the green color. So the second control signal is what? Help me.
Address stroke.
Address stroke, and the second control signal is what? Okay. Now, if you look at here, now we are connecting it to the main memory, and now this is my main memory side. So if you look at my main memory side, so this is my main memory side now. And if you look at the main memory side, so we have M. M is 12. Please remember, M is now 12. So the address lines from here will be what? From the memory side will be what? This is actually okay. I can call I can use the red color here. So I can connect here. What you can do here? So this is what? M11. Then what? M10 and blah blah blah. I'm up until what? M00. So what is M here now? M's 2. And if you go for the data lines, what is W? So what I can write here? Help me. W what?
07.
W07, then W06, and blah 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 until what? W06. So can you see here? What is this thingy? W is 8. And now we have address stroke. Okay, now we have three control signal on the memory side. What is the first control signal?
Chip select.
Chip select. Now we have chip select here. Then we have what? Help me. OE and then what?
Right enable.
Okay, what we need to do? We need to connect A11 to what? M11, A10 to M10 and blah blah blah, A9 to M9 and blah 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 and A0 to M0. And then D0 to what? Help me.
W.
W07. So we are just connected. Where should we connect AS? Chip select. A is connected to chip select. Where should we connect read write bar?
Not gate.
No, OE. Because read write bar. And then this is the memory system design when A is equal to M and D is equal to W. So when the address lines width on the microprocessor side is equal to the address line width on the main memory side. Clear or not clear? Okay, please remember, in the exam, this may be the question in your midterm. If in the exam, if I flip, I put a bar on R, what should I do then?
The knot goes on.
So the knot goes on OE. Clear or not clear? Okay, so this is actually, now please remember, this is how do we connect a microprocessor with the main memory. This is, okay, please remember. And now, if I want to draw it in a compact way, okay, this is not in a compact way because there are 12 address lines, then there are W data lines, there are 20. Okay, how many pins are required on the main memory side? So 12 plus 8 plus 3. How many pins are required? 23 pins. So here on the memory side we need 23 pins. Let's assume if A is 64 and W is 32 and I want you to draw. Can you draw the whole thingy? Like individual line. You cannot draw the individual line. So now I will tell you now the compact way that how do you connect this? How do you connect this microprocessor with memory? So that basically what I will do is something like this in a very compact way. So this is my microprocessor side. This is now my memory side. So I can write it like here. So these are multiple lines. So what I will write? Please remember, I will do it like this. So this is actually A11 to A00 on the microprocessor side. It will be connected to what? W11 to W00 on what? On the memory side. Sorry, not W. M11 to M. This implies that A11 is now connected to M11, A10 is now connected to M10 and blah blah blah. So these are the multiple lines. So this is a more compact representation. So if the number of address lines are more, so you have to draw it in Nizami way, like this way. Okay, now here then we have the data lines. So what we need to do here? Please remember, the address lines is unidirectional and data lines are what? Bidirectional. So data lines, so if you data lines is bidirectional because either we are storing the data into the memory or either we are loading the data from the memory. So the direction of the data will be from the microprocessor to the main memory if it is a store operation, and the direction of the data will be from the main memory to the microprocessor if it is a load operation. Okay, so either it can be a read operation or it can be a write operation. Clear? Okay, now data lines is bidirectional. So what we need to write here? What do you need to write here? D11 to D00 will be connected to what? W11 to
0.
Professor, it's 8?
Yeah, the 8. You're right, 8. In this example is 8. And then the address stroke will be connected to chip select, and then read write bar will be connected to OE, and the invert of read write bar will be connected to. So this is now a more compact representation, and I will post some more questions on iLearn. And please remember, this will be one of the question today. From today's lecture, there will be one question will be asked from today's lecture. Any question? Should we proceed? Your choice. If you want to study it and you don't want to study it, up to you. Now please remember, I solved it here on the board, but this is also the solution. So this is how it works. Clear? Any question? This is the same thing. Now, what I'm going to do, now I'm going to rub this off because now I'm going to do another example. Okay? So now this is case number 1 or case number 2? Case number 1. Okay. Now what we are going to do, so I'm going to rub this off. So now we are studying case number 2. In case number 2, please remember, now we have studying case number 2, so case number 1, so now we are studying case number 2. In case number 2, A is greater than M. And what about D? D is equal to W. Okay, it means that address lines on the microprocessor side is greater than the number of the address lines on the memory side. Now we do it with some example. So okay, now please remember, now if you look at here, what is now the memory requirement of a microprocessor? So the memory, and after this class I will give you one mock quiz. That may be the quiz on your midterm. Anyone who will solve it correctly will get 1 bonus mark. I will give you some time. It's up to you, your choice. Okay, so now we have the main memory requirement of the microprocessor. So the memory requirement of the microprocessor. So now we have the microprocessor side. So now microprocessor side is now the red color. So the main memory requirement of the microprocessor. What is the memory requirement of the microprocessor? 16 kilobyte. And please remember, the memory requirement of the microprocessor side is actually, okay, so the memory requirement is actually 2 to the power A cross D. So this is actually 2 to the power A cross D. And the width of the data bus is 8 bits. What's given? D is given. So D is given. So D is what? 8. So can you see here? So this is actually 16 kilobyte. And then you can say 2 to the power A cross D. And then you can see here, so this is 16 is actually what? This is actually 2 to the power 4, K is actually 2 to the power 10, and B is actually 8 bits. Okay, so this is actually 2 to the power 3. And then we have 2 to the power A, we need to find A, and cross D, D is given 8. So can you see here 2 to the power 4, 14 cross 8 is equal to 2 to the power A cross 8. And 8 will cancel out. What is A now? 14 now. Okay, now please remember this is case number 2 when A is greater than M. What is the value of A? So A is actually 14, which is greater than M. Now we need to find M. What is M? Okay, now here M is given. What is M? 12. What is W? Okay, now please remember this is very important now. And now I will give you some tricks. I will give you a lot at the end of the lecture. I will give you a formula which is a very generalized formula. Okay, so now can you see here? Now the main memory or the memory available. What is the main memory available? What is the main memory available? It is actually 2 to the power 12 cross what? 8. If it is 2 to the power 12 cross 8, now we have the main memory available which is 2 to the power 12 cross 8. Can we do it like this? 2 to the power 2 dot 2 to the power 10 dot 8. Yes? What is 2 to the power 2? 4. What is 2 to the power 10? Kilo. And then? Okay. The main memory available, main memory requirement of the main processor is 16 kilobyte. And the main memory available is what? 4. How many such memory do we need? So okay. So number of memory chips required. So please remember the number of chips required, the main memory chips required. So the number of memory, please remember this number of main memory chips required. There are two formulas, and I will give you that formula. The number of memory chips is equal to main memory requirement divided by main memory available. Memory available. What is the main memory requirement? Tell me. 16 kilobyte, and the memory available 4 kilobyte. Kilobyte will cancel, so we need 4 such memories. So now we need to know that how we need to connect these 4 memories with the microprocessor. Got it or not? So now we have 4 memory cards. Okay, there is another formula, and that formula is also the number of memory chips is also equal to, this is equal to 2 to the power A cross D divided by 2 to the power M cross W. This is equal to 2 to the power A, which is actually 2 to the power 14 cross 8 divided by 2 to the power M 12 cross 8, and if we compute it, so 8 will cancel out, and then it will be 2 to the power 2, which is actually 4. So this is another formula. I will give you a lot of formulas here. Any question? Okay, now think. Now, what is A? What is the value of A? A is greater than M. So A is greater than M. What is A here? A is 14. And M is 12. What is the value of D? So D is equal to, W is equal to 8 in this particular example. So this is case number 1 or case number 2? Case number 2. And in case number 2, okay, please, in case number 1, we only require only one memory. But in this example, we require how many memories? 4 memories. And if we require 4 memories, and I also give you, please remember, in this case, we will read, either, in all of the cases, either we will need some of the rows and some of the columns. Okay, in this case, if it is case number 2, so please remember, I am now giving you a formula, and the number of rows will be actually, this is a general formula. The number of rows will be equal to 2 to the power A cross 2 to the power M. So this is actually 2 to the power A minus M. And what is A? 2 to the power, what is A here? 14 minus M, 12. 2 to the power 2. So we need how many rows? And 4 rows is actually the number of chips. And now how many number of columns will be there? So number of columns will be equal to 1. And how? I will explain it now. Okay, so now what I'm going to do, I'm going to rub that off on that side. I'm going to rub that side because I'm now going to solve this question and I'm going to design the whole system now. Should I write this up? Okay. So now what I am going to do? Now we have the microprocessor side. I'm now using the red color for the microprocessor side. So if you look at the microprocessor side, so we have the microprocessor side. And we have the microprocessor side, so we have A. A is the width of the address lines. So if it's the width of the address lines, what is the width of the address lines here? Help me. A what?
13.
Yes, A13 till what? A00. Now we have the data lines. I'm not using the black color for the data lines. So for the data lines, it is actually what? D what? D07 till D00. Then there we have some control signals, and for that control signal, I'm now using the blue color. So we have the control signal, which is actually what? Address strobe and read write bar. Okay, now in this particular example, how many rows are required? 4 rows. How many columns? And we need 4 memory chips. Please remember, we need 4 memory chips. If we need 4 memory chips, so can I write it here? So now this is my chip number 1. So this is my chip number 1, memory chip 1. This is my memory chip 2. This is my main memory chip 3. And this is now my main memory chip 4. So now we have 4 rows. Row 1, row 2, row 3 and row 4. Now if you look at the main memory, please remember, now we have, if you look at the main memory. So what is now M? M is 12. And what is, M is, yes, 12. And what is W? 8. If M is 12, so can we write it here? So now we have what? This. Please look at here. So now we have M, which is actually what? M11 to M00. Am I right? Then here, M11 to what? M00. So these are the pins. These are the address pins. Then we have M11 to M00. Then we have M11 to M00. Got it or not got it? Then we need something on the data lines. On the data lines, so now what are I going to do? What will be under data lines? Help me. Yes? Should we use W or D? W. W07 to W00 because I'm now using a label up. So this is actually 8 data lines. So W07 to W00, then we have W07 to W00, and then we have what? We have W07 to W00. Any question? Okay. In addition to that, we have 3 control signals, and these control signals are what? Okay, please remember, this is actually chip select 0, so chip 0, memory chip 0. So main memory 0, main memory 1, main memory 2, and main memory 3. So these are 4 memories. Okay, so basically I call this is main memory 0. So can you see here? So we have chip select 0, OE 0, and WE 0. Then what? Help me. Chip select 1. OE1, WE1, then chip select 2, OE2, WE2, then chip select 3, OE3 and WE3. But now $1 million question. How do we connect this microprocessor side to the main memory side? Okay, so now what we are going to do, so in this case, this is a little tricky, Okay, please remember. So now in this case, we have 14 address lines on the microprocessor side and 12 address lines on the main memory side. Clear? Okay, now the lower, okay, now if we partition this A13, so we partition this A13, then A12, then A11, then A10, and blah 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 until A1 and A00. How many address lines are on the microprocessor side? Help me. 14 lines. We partition this into 2 parts. Okay, so now in here, so this is actually 12 lines, and this will go to M. So A11 will be connected to what? W11. A10 to what? W10, and blah 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 until A00 to W00. So all of the address lines, so can you see here, this is connected to what? So this address lines, okay, now please remember, so we have now A11 to A00 will be connected here, and then A11 to A00 will be connected here, then here A11 to A00 will be connected here, and then A11 to A00 will be connected here. What about the remaining 2 bits?
Mux.
No. What about the remaining 2 bits? Anyone? No. Because we want to, okay, now please remember, there are 4 memories. And please remember, I will explain one more important thing, and that will be paired with the question of your midterm. So now the problem is that we have 4 main memories. 4 memories. Memory 0, memory 1, memory 2, and memory 3. So the lower bits of the address lines of the microprocessor are connected to the address lines on the main memory side. So okay, we need to enable one memory at a time.
Chip select of the number.
We need to enable one memory at a time. So we need a hardware structure, digital system. We need to enable one at a time. Which structure allows us to enable one decoder? Why? So we need a decoder. Okay, please remember. Now if you look at here, decoder, so now we need a decoder here. And the input to that decoder is actually what? The most significant. If you look at here, so this will go to, okay, how many bits are there left? 2 bits. So we have 2, so we need 2 to 4 decoder. If there are 3 bits, then we need 3 to 8. If we have 4 bits, 4 to 6. Got it? So this will go to a 2 to 4 decoder. So now we have the decoder size, the input size of the decoder. So now the input side of the decoder, A13 will go here, and then what? And there are 4 outputs of the decoder. There are 4 outputs of the decoder. So this is actually, okay, so now we can see here, so now this is the first output, so basically we have 4 outputs. So we have D0, D1, D2 and D3. This will be enabled if it's 0, 0, 0 enabled 0, 1, 1, 0 and then 1. And this decoder, this will go where? This will go to chip select 0. And D1 will go where? Help me.
Chip select 1.
Chip select. And D2 will go where? Chip select 2. And D3 will go where? Chip select. Any question? Okay, now, when this decoder should be enabled? When this decoder should be enabled? When this decoder should be enabled? Digital system. This decoder should be enabled when microprocessor generate a valid address. So this address strobe will go where? Help me.
Decoder.
To the enable of the decoder. So it means that now we have an enable signal in the decoder. So the address strobe will go here. Okay, now I will draw it. Please remember. Now this is now my digital system. This is now my digital system. So please remember the digital system. So now the digital system scenario. Okay, so now if you look at the input to the decoder, so we have enable. So now we have enable on the decoder size, and then we have A13, then we have A12, and the output is what? Help me. The output D0, which is actually chip select 0, then we have chip select 1, then we have chip select 2, then we have chip select 3. Okay, if enable is equal to 0, it means that microprocessor has not generated any valid address. So it means that A13 and A12 will be ignored, as the poor professor is ignored by all the students. They are busy in their mobile preparing for their quiz today, I know that. Okay, what if they will have chip select 0, 1, 2, 3? No. We have to disable them or enable them? Disable. So please remember, did you forget the truth table of a decoder? So if the enable is 0, all the outputs of the decoder is 0, 0, 0, 0. It means that all chips are disabled. Our chips are disabled. Okay, now if enable is equal to 1, then it depends on what? Then it depends on the A13 and A12. So we have 0, 0. Which memory will be enabled? Chip select 0, 1. So the first memory will be enabled. The top memory. and we will get the data from there. But now, and there is something missing. Okay, if it's 1 and 0, 1, help me. Chip select 1, 0, 1, 0, 0. Then 1 and 1, 0, 0, 0, 1, 0, and then 1, 1, 1, 0, 0, 0. Any question? Any question? Okay, now, but still, where should we connect RW bar? So RW will be, okay, please remember, RW, so now I'm not going to, because I connected, so it will make very messy. So R slash W bar will be connected to what? It will be connected to OE0, OE1, OE2, OE3. And the invert of RW bar, if you invert it, it will be connected to what? Help me. WE1, WE2 and WE3. Okay, I can make a connection here. So I can make a connection here. So I will make a connection here and then the invert of that, but it will miss. Any question? Any question? Okay, please remember. Now this is very important. This is only one aspect of the main memory system design. But now I will tell you the another thing which is very important. So what I'm going to do is I'm going to rub this off. I'm going to rub this off and then I'm going to explain from a different perspective and from a different angle. Okay, now, should I rub this up? Should I rub this up? Because I'm going to rub this up, because I'm going to, we need to visualize the stuff that's going on. We need to visualize. So what am I going to do? So I'm going to rub this up now. And now I will explain it. I will explain it from the concept. I will explain it from the concept of the physical memory. How? Let's see. Should I rub this out? So I'm going to rub this out. This part. I'm going to rub this out. So